Hello. So last class we studied Pythagoras theorem. You remember, no? With the basis of the trigonometry chapter, we were actually doing the Pythagoras theorem. So the Pythagoras theorem, if this is a right triangle, okay, if this is a right triangle, triangle A, B, Z, I told you the side opposite to this one is called a hypotenuse, right? So these are the sides. This is also another side. If you want, you can call it as base, and this is altitude. That is actually what we can say, right? Okay, anyway, forget it. Now, the Pythagoras theorem says that AC square, the bigger side square, the square of the bigger side is equal to sum of the squares of the other two sides. Squares of these two sides, you take it, then add it. So sum of the squares of the other two sides. This is actually what we learned in Pythagoras theorem. This is very, very, very important. We are actually going to use this Pythagoras theorem in this trigonometry chapter. So once again, if this is a right triangle, okay, then if you call it as this is P and this is Q and this is R as actually the three sides, then P square is equal to square of the bigger side is equal to sum of the squares of the other two sides. So that is what is Pythagoras theorem. I hope you understood, and we did some problems, and most of you people submitted correctly, and I'm very happy with that one. Now get into the next one, that is the trigonometrical ratios. Before getting to the trigonometric ratios, we really need to learn more about this right triangle. What did you call this side? If this is marked as right triangle, then this is called a hypotenuse. Okay, then this is ABC, ABC. Then what is this side called? I told you, base. So it's, the triangle sits on that. So it's the base. And altitude. What is the meaning of altitude? Altitude means height. Height of the triangle. So this is the height of the triangle. No confusion. This is base of the triangle. So base and altitude. If I take a triangle like this, see a triangle like this. This is a right triangle like this. And this is, as I told you, base. This is right triangle. And this is the altitude. Right. Suppose if I turn like this, what will happen? What will happen? This is again the right angle, so this is going to be the hypotenuse. See, it is written base, but you know this is the altitude. It is written altitude, but you know this is the base. So, if you change the triangle side, no, it actually changes. That is not allowed in mathematics. If you are writing something, that should be same everywhere. So, if you write base here, it should be the same base every time, but that is not possible when the triangle changes its sides. So that is the reason why we are actually most of the time not calling it as base and altitude, because it changes. Now in this scenario, we are actually going to see the triangle in some other view. Again a right triangle, A, B, C, right angle. Okay, right angle means what? 90 degree. Yeah, you know that. 90 degree. So, what is this side called and what is this side called is actually the big problem. I told you, when it changes, the base and the altitude changes. For that, we fix one angle. Now, to avoid that confusion, the base and altitude confusion, what we are actually going to name all these three sides with respect to this angle. If you consider this angle, okay, before coming to that, let me ask a question. If you consider this angle, then this is called a hypotenuse. See, whether you are going to consider this angle or this angle, doesn't matter, hypotenuse is going to be the same thing because it is actually opposite to the 90 degree angle. So that is clear. Now, consider this angle. If you consider this angle, then this side is called opposite side, and this side is called adjacent side. What is meant by adjacent? That means very near to, very near to. Two adjacent rooms means very close to each other, having something common. So adjacent side of this angle, opposite angle of this angle. See, take another triangle here. It's a right triangle. So this is the angle you are selecting it. So this is, I told you, adjacent side, and this is called opposite. Now turn. What is going to happen? It is going to be the same thing. See, it is opposite again, it is adjacent again. So it never changes. So that means when you take an angle, then it doesn't change. Now, if you take this angle, what will happen? Then these two will change. Because if you consider this angle, the opposite side is this one, BC. And if you consider this one, two adjacent sides are there, but one side is already labeled as hypotenuse. So we cannot touch that. Then this is going to be the adjacent side. Clear? So that is something very important. Naming the sides of the triangle with respect to a non-90-degree angle. Once again, naming the sides of a triangle with respect to a non-90-degree angle. Once again, a very quick review. See, this is a 90 degree, this is a triangle ABC. This is the angle we are going to consider. Then what are the names of these three sides? So, of course, this is going to be respectively, what is going to be that one? It is going to be hypotenuse. Then, with respect to this angle, this is called the opposite, because it says that it is actually the opposite. It is going to be the opposite side. And for this side, we have two adjacent sides, but doesn't matter. This is already labeled as hypotenuse, so this is going to be adjacent side. With this information, we are going to define the trigonometric ratios. Thank you.